I'm back. So a very warm welcome again for everybody who is present for this session on the introduction to big data and data loading techniques in Hadoop. Just in case some people must be wondering that why did this guy say I'm back. So I logged in some time back and we just did a bit of sound check. So very warm welcome for the guys who have just joined us in last 10 minutes or so. I can see that in last, not 10 actually, around 8 minutes, almost some 30 more people have joined us and more are joining by the time I'm just speaking. So very warm welcome guys. So guys, my name is Vishal Kumar, and I'll give a quick introduction about myself very soon. So let others to join. We'll just get started because there are pretty good amount of stuff which we plan to touch upon in this session. So guys, let's just start. So hi everybody, my name is Vishal, as I just told you. I'm having around 15 years of overall industrial experience, and when it comes to the big data and analytics area, the experience is almost now 5+ years overall. When it comes to the big data and analytics, and specifically when it comes to the domain of big data, so my experience, just like most of my, the people who just started along with me, my experience also started with Hadoop, and then after spending some time now, I moved on to some of their frameworks like, there's something called Storm, then Spark, and over the period of time, now I specialize in the area of coexistence of big data systems along with the coexistence of the big data systems along with the existing enterprise systems. So that's my area of specialization. And when it comes to the functional areas in which I have typically worked, so I have spent most of my time into the retail industry and into the finance domain, I would say. There were a couple of projects which I have done for the telecom domain as well as for the healthcare domain as well. So that's pretty much about me in terms of overall years of experience or the kind of technical or domain-wise expertise which I typically carry. And more about me you'll keep on discovering over the period of time when we'll be there together for the batches of Hadoop. So okay, in between, before I proceed forward, I just saw some of the things on questions tab. Somebody says that I think it's Suraj, who says that he's not able to hear me, whereas I hope others are able to hear me. Could you guys please just confirm? I hope you are all able to. Nice. So Prakash and others are verifying on this side that yes, they are able to. So seems like this must be the individual endpoint, bandwidth related issues sometimes. So hi Sahil, hi Ranjit and others, everybody for confirming. So thanks a lot about it. So before I move on to the session objectives, guys, since this is a webinar, of course, in this webinar there are a lot of people, and the overall duration of this webinar is going to be around 1 hour. So about the questions, stuff and other things, definitely whenever we hear somebody's idea, questions and doubts are the essentials part of it. So I will do my best to answer most of the questions. I'll have to go for the batching kind of a technique, wherein I'll constantly keep watching the questions tab, and whatever are the common questions, I'll just try to club them together and try to answer. But still, if you are not able to get the answers, I'll be leaving some of the handlers at the end of the webinar, wherein you can post your questions and you can get the answers as well. So let me just continue on the session's objectives, what we plan to cover. Guys, the first thing first, we will start our journey from the root itself. So, data loading technique and things like that. If you just come to that part, before that, why are we even talking about the data loading techniques to big data world? Why are we even talking about Hadoop, right? So, why should even I care about it? And then, the moment I talk about it, people definitely have some answer. See, you know what? Hadoop and other things, we definitely care about it because it is a highly paid domain. Probably the other look or I would say under angle of looking into it is no, it really helps us in solving big data problems and all. So then I will ask back the question that what exactly big data is. Rather than me asking this question, probably we should ask this question to ourselves, and that is what I plan to do in this brief part of introduction to big data and Hadoop, wherein we'll be starting off the problem directly from the root. Of course, it's just 1 hour duration, so we'll be touching base on some of the points. There are detailed discussions of around 2 hours plus, in fact, in the actual classes. But yes, we'll just try to get a high-level overview of it. And then we'll be talking about, or we'll even be demoing 1 or 2 very small things about, Hadoop cluster. There is, in fact, Hadoop is kind of an ecosystem. So what exactly are the different components? How do they really enable you to do certain set of activities and things like that? So those are the points which I'll be covering in the understanding of Hadoop cluster and data loading techniques in Hadoop. Most of our sessions are typically based on the hands-on part. So of course, I will also be following the very same thing. Even our webinars also are no exception of it. I'll try to cover those things. And then last but not the least, it would be about we have handpicked some of the questions about commonly asked questions in Hadoop world altogether. Some of you would have already faced it. Some of you might be planning to face those questions. So in fact, this is just, I would not even say, we are not even scratching the surface with these questions. These are like basic minimum things. If somebody doesn't answer, particularly if somebody doesn't answer these questions to me, I generally don't consider that candidate even for the next round of interview sort of thing. So these are just some of the things, some of the common kind of questions which I would like to clarify at this point of time. And then there would be a bit about specifically about the Skillspeed offering. What exactly makes it differ? Again, it's not going to be the sales pitch that we typically don't want it to be that way. It should be value driven sort of. So let me just get started, guys. I think all of us are good about the agenda, about the things which we plan to cover, and I just hope most of you are able to hear me and other stuff. I'm seeing 1 or 2 casual can't hear any video, any audio, and I'm sure it is just the individual end point problem rather than a general problem. Am I right, guys? May I just move forward? Thank you, Jayed, for confirming, and thank you others as well for confirming. Mohit, Rajesh, Prakash, others. Sure. Okay, so with this, let's just get started and just have a look of this single sentence. Not even a sentence, it's just a collection of words altogether. Big data and its challenges. Okay, so let's take it step by step. So big data and its challenges. When it comes to that, what exactly is big data? Okay, before I explain about it, you can in fact have a look of this funny caricature which you are seeing on the left hand side, that how is the big data project coming along, any employee name, and then that person, forget about the response, you will hardly see the person. Anyway, this is just a caricature as people know about it. But yeah, on a serious note, guys, what do you think is big data? In fact, I would encourage you, even if you are not looking at the screen right now, don't look at the screen. You can close your eyes and then think about whatever sources you have thought or probably some of you might already be working in some of the center of excellences of big data, or some of the big data teams altogether. So what exactly do you mean by that? As Chetan was rightly pointing out, that it simply means huge amount of data, huge volumes of data, and others. There is absolutely nothing wrong about it. Yes, you are totally talking about that huge amount of data. Now, that's where the question comes. How do you define something as huge? How do you define that it's huge amount of data? Now, let me tell you a bit point here, and that's where it will force you to think. Some 3 or 4 years back, I have not really asked about people's people's background, but based on my experience of taking various webinars, I know that most of you would be coming with some experience. Some of you would be starting their career and all that stuff. But yes, those people who have, let's say, worked in the database area, right? You must have seen that in past, let's say not more than 4 or 5 years back, if your database administrators used to say that, hey, you know what, if your database file size is more than several GBs, 5 GB, 10 GB sort of, then you're dealing with a huge amount of database instance or a big data instance altogether, right? This was the scale just 5 years back, whereas the scale has moved forward today. We are talking about that if you are dealing with the volume of the data which is in late GBs to the early terabytes. I'm talking about, when I say late GBs, I'm talking about 600 GB data, 800 GB data, to early terabytes, 5 terabyte, 10 terabyte kind of data. This is typically accepted as kind of, you have started going for the big data kind of instance. Whereas probably for the companies like Facebook, Google, eBay, etc., probably this scale is several petabytes as well, right? So this, the overall point which I want to bring here is, it is actually a moving target. Several years back we were talking about early GBs, then we are talking about now late GBs and early terabytes. Probably, some years down the line when somebody else would be taking this kind of webinar, they would be talking at the, late terabytes to the early petabytes kind of thing, right guys? So the definition of huge amount of data itself, I hope that part should be quite clear, right? It is just a moving target. Now, is this the only thing? Is this the only thing which makes big data such a I would say hot area, or I would say such a highly paying area? No, not really. So what exactly are the things which come along with this package, right? What exactly makes big data domain such a different I would say such a different area to deal with, right? Let me purposefully when we were preparing these presentations, there was a specific slide which typically talks about, I'm sure most of you would have heard, 3V of big data, 3V characteristics of big data. I have purposefully removed it. I have removed that. The reason is, it is very easy to see in the slide, but it is very difficult to realize what it really means, right? So now, let me quickly talk about it, right? Just a second. So, what exactly are the different challenges which come along with this huge amount of data? Guys, simple. What is the hard disk drive capacity of your laptop? Typically, right? You don't really need to type. You don't really need to type the answer of it, but typically it would be, some 250 GB to 500 GB. Some of the newest laptops or the best laptops would be having around 512 GB or even 1 terabyte, right? 1 terabyte sort of thing, right? So that is the typical hard disk size. Now, so maximum you can save up to 1 terabyte of data into this. But if I'm talking about huge amount of data, let's say 5 terabytes, 10 terabytes amount of data, then can you save this much data into a single machine, into a single server? Typically you cannot. Okay. Now that you have realized the first thing, that you are talking about a huge amount of data, it is just not the storage, it is the distributed storage to which we come into picture, right? So now you cannot really store your data into a single disk or into a single machine right, which is the collection of multiple disks altogether, probably you would be needing multiple machines to store your data, right? So the first difference comes at the storage level itself, that your data becomes so huge that it can no longer reside in a single machine. It has to be there in the multiple machines, and you're talking about the distributed storage right now. Now, okay, so we understand that the first part is the distributed storage. What is the next challenge? The next challenge comes, what will you do by storing the data? What will you do? You typically store the data because you can process it, right? So that you can get the information of the out of the data, right? Data itself is worthless or valueless. You do the processing of the data, and then you create the worth out of it. You create the information out of your data, right? So basically you're talking about the data processing part of it. Now, if your data is on a single machine, and let's say even if it is a slightly on a higher side, talk about 5 MB file, 10 MB file, probably you can write a simple Java program or simple Ruby program or whatever, right? Just write a program, let it run for some time and get the output. That's the typical way. But when you're talking about your data being spread across different machines, right? The way you were writing your program earlier itself might not succeed, right? The way you were writing your programs earlier with taking some input, creating the output, that would not succeed, because now your data is available across different machines. Now your data is stored across different machines. Now, the moment you have talked about it, you are actually going into the direction of distributed processing. Are you guys getting my point? That what the next complexity eventually which comes along with it is the distributed processing part. So that is the next complexity which comes along with it. It is not just the volume part. Volume was just one attribute which brought the challenge of storage, which you had to go for the distributed storage, and then the evolution of the distributed file system started. And similarly, you had to go for the distributed processing kind of a paradigm instead of a central processing kind of a paradigm. And then the evolution of distributed processing systems like MapReduce, like there are several Stage, then there is something called Spark, and so many things have, have evolved over the period of time. So these are some of the things. But okay, now we understand that we are talking about a volume part, and that volume actually makes the life difficult for you to process, to store this much amount of data using the traditional systems, right? So these are just some of the challenges. But is this the end of those challenges? I'll touch base on those parts very soon to you. Okay, so now let's quickly defocus from that and then just think about it. Who generates the big data? Now these three names, no prizes for guessing it, right? They are the typical generators of big data, huge amount of data and other stuff. But again, guys, are they the usual suspects? Are they the only ones which generate the huge amount of data? Talk about any big retail company like Walmart, right? The amount of data which they typically generate from all of the point of sales. Talk about all of the banks which are generating all of the transaction related data. Talk about, yes, as Abhijit is saying, like, Amazon, eBay, etc., etc. But again, aren't we again following a pattern? Aren't we again following a pattern of thinking that, okay, probably either the companies which are typically for the social, social networking sites, or probably the companies which are kind of, doing some sort of online transactions or something, they are the ones which are generating the data? Are they the only ones? No, not really. In fact, you know what? The origination of the big data term itself, right? The origination of the big data term itself has nothing to do with IT. It has nothing to do with IT. This term was originated in early 2000s in the area of genomics and in the area of basically astronomy part of it, wherein a lot of satellite images and other stuff have to be processed, and that data used to be such a huge one that again, using conventional systems, you could not do anything about it at all. Okay, so basically I hope all of you can easily understand it, right? The sensors data, you know, those jet flight sensors, right? Just for a 30 minutes flight, these sensors typically generate 1 terabyte of data. 1 terabyte of data for 30 minutes flight. Now just think about a flight which connects Delhi and Mumbai, right? Delhi and Mumbai. Then you're talking about such a huge amount of data. And then think about all of the flights, or just a flight which is connecting both the ends of Atlantic. And now think about all of the flights which are connecting all of the endpoints in the world in a given day. It's a huge amount of data, right? And it's not being generated, by the way, from YouTube. It's not being generated from Facebook, right? Another part is, this is not just the volume part which I'm coming to. There is something else which I want you to think about it, right? So it is definitely the volume part of the data which was important. The second part is the rate at which you are gathering this data. 30 minutes, 1 terabyte data. Just to gather this data, forget about processing, just to gather and store this data, it's a huge challenge, isn't it? And that is something called velocity. That is something called the velocity, or the rate at which you are consuming or processing the data, right? That is the velocity part. Third part, I talked about Facebook data, your post, your photos, whatever you upload on Facebook, people who like it, people who comment on it. Then the sensors data, then the data which is generated, a very structured kind of a data which is generated from the banks and all. So these are all different kind of data, isn't it? You have structured data, you might be having unstructured data completely, you might be having some sort of semi-structured data as well, right? That part goes to the variety part of it, right? So basically these are called 3 V's of big data, 3 V characteristics of big data. Volume, no need to explain. Velocity, I hope all of you understood, because we are talking about the rate at which you are either crunching or you are collecting the data. And third, last but not the least, it's about the variety of the data, which can be anything, right? So guys, I hope so far so good. Everybody understood it very well about what exactly are the most important characteristics and the challenges which come along with big data. What makes it so hard? Are we all clear? The thing is, I can just get started from Hadoop, but you should definitely understand why entire thing has started and why entire thing has become so popular. What were the main challenges, right? Everything should be able to understand it very, very clearly about it, right? Okay, there are few people who are talking about, please explain the velocity. So guys, when I talk about the velocity, it's all about the rate at which you are collecting the data. I just talked about it, right? 1 terabyte of data. It's a huge volume, but 1 terabyte of data you are collecting in 30 minutes. That is called velocity. That is the rate at which you are collecting the data or probably processing it, right? Shahji and others who asked this question, you were the last, that's why I'm taking your name, right? Shahji, I hope it should be quite clear to you. Now I'm just moving forward. Okay. So now with this, so Hadoop is something which can definitely solve the problems for you, okay? Which can definitely provide you the processing of such huge amount of data, right? Now I'm just going to answer you how exactly. So before even I come to that, we first should understand what exactly is Hadoop. And even before I tell you what is Hadoop, let me just tell you, what exactly is the kind of problem which Hadoop tries to solve. Yeah, Anshul and others, I'll immediately tell you about all those aspects, okay? So now, when you come to the processing part of it, data processing, I'm sure all of you would be aware that you can process the data in 2 different ways, right? You can process the data in 2 different ways. Typically, there is one kind of processing wherein, let's say, you have done a banking transaction. You went You withdrew some money. So the moment you withdrew some money from ATM, your account balances got updated. You got the message saying that, hey, you have withdrawn so and so money and your account balance is XYZ, right? This is called OLTP, online transaction processing, or the real-time processing, right? It is called the real-time processing. Whereas if you take the another kind of processing, it's, let's say you have got the banking transaction for entire day, right? And then banks typically run an application called EOD, end of the day operations. What happens in those end of the day operations whenever banks close their day? Basically, they do all the accruals, all of the calculations, all of the balances, general ledger balances, etc., etc. Everything gets updated at that point of time, right? So that is called the batch processing, wherein you are collecting the data for some time and then you are processing that all together, right? That is called the batch processing of the data, right? So Hadoop is most suitable for the batch processing of the data. Hadoop is not suitable for the real-time processing of big data. Okay, for real-time processing there are other tools, something called Spark, something is called Storm, and there are several others also. But yes, that's a different domain. But Hadoop focuses, and Hadoop has become an industry standard about the batch processing of the data, right? So first I told you what exactly big data is, what exactly are the challenges. Then I'm telling you about, what aspect of big data is Hadoop trying to solve. Now let's come to the point. What is Hadoop? Okay, guys, this is a question which I have asked, I don't know, in almost every interview whatever I have taken, for at least for the people who are starting their career in Hadoop. You won't believe, even the people who claim that I have worked in in Hadoop area for basically 2 years and things like that, they give me some funny answers. Some people say that Hadoop is a tool. Some people say that Hadoop is a database, Hadoop is a language, and so many things, right? But guys, if you want to just get a takeaway out of this webinar, even if you don't remember anything whatever I have said, just remember Hadoop is a framework. Hadoop is a framework. It's neither a language nor a database nor a kind of a language, or I would say whatever tool, or there are several things which people call it, right? It is a framework. Now what exactly is framework, right? So framework is typically the thing which gives you various utilities to perform the things, right? To perform various things. So what might be the best example? Let's say struts is a framework. Hibernate is a framework. Ruby on Rails is a framework. Take the example of Ruby on Rails. Ruby on Rails is a framework which allows you to do the web development very, very fast. And what it typically does is, you typically follow a specific kind of conventions, and then remaining things it does for itself, right? You just follow some of the conventions, your model layer, view layer, controller layer, everything gets created by itself, right? And then you just focus about the business logic area, right? Just focus on just the business logic, and remaining things are done by the framework itself. Similarly, Hadoop is actually a framework for you. So it is the framework which is going to provide you the storage capabilities, the processing capabilities, the abstraction capabilities, the data loading capabilities, the data exporting capabilities, interfacing capabilities, some sort of querying capabilities of the data. So all of these are the different capabilities which you would require to do the batch processing of data, right? And that's where we call Hadoop as a framework. So I hope everybody now understands that Hadoop is a framework which is trying to solve the batch processing aspects of big data, right? So I think somebody was asking me a question, what is the difference between Hadoop and big data? And I hope now you have got the answer, right? I think it was Naveen, that Hadoop is a framework which is trying to solve the batch processing related problems of big data, right? Now, what exactly are the different characteristics of Hadoop which make it very exciting? So guys, One, Hadoop is very economical. So Hadoop clusters are created out of the commodity, commodity machines. When I say commodity machines, the machines like your laptop, my laptop, and you have collected 10 such machines, created a cluster out of it, right? So these, your machine, my machine typically are cheaper than the, let's say, IBM servers, right? So typically they are the ones which basically go for the economical part of it. Instead of going for the vertical scaling, you are talking about the horizontal scaling, about adding more and more cheaper machines rather than making a single machine even more costlier, right? So that is from the perspective of economic perspective. They are scalable, as I just said, that you need more processing power. You can keep adding more and more machines to a Hadoop cluster. Okay, so you can use more and more machines. You just keep adding more and more machines to gain more processing power. So that goes for the scalability part of it. Hadoop is quite flexible as well. So when I talk about Hadoop is quite flexible, it's all about you can process the structured data, unstructured data, semi-structured data. Every kind of data can be stored as well as processed in Hadoop. That is another advantage of it. And Hadoop is quite reliable. So now, this is something which is very interesting about Hadoop. So when I say Hadoop is reliable, it's all about that, you have the, in distributed world or in Hadoop world, failures are not unexpected. Failures are always expected, right? Just assume the scenario you had, created a cluster of 10 machines and somebody goes and, plugs out the network cable. Very much possible, right? Very much possible. Or probably just the network connectivity was bad for a specific machine. Right now also you people are listening to me. Some of you were saying voice is not clear, and then the voice becomes clear to you, right? Some of the network issues. Right now also we are talking about in a distributed fashion, right? So these are the various things which are very much expected. But yes, Hadoop as a framework provides you the provisions of doing the automatic failover. Okay, fault tolerance and failover, these things are, these kind of characteristics are built in the Hadoop framework. Okay, you don't really need to focus about what would happen if somebody plugs out a network cable. How will my program run? How will it access the data, whatever was available on that machine? You don't really have to worry about it. Framework takes care about it. You as a programmer are going to worry only and only about your business logic. Is that clear to everybody? In between there were some interesting questions. I would not be able to answer all of them, but some of them probably. Somebody says Hadoop, can I use Hadoop for the real-time processing? No, not really. I just explained it some time back, right? Then somebody was asking, are you saying Hadoop can solve only batch processing aspect of big data, or is it one of them? No, I'm just saying Hadoop is the best to solve the batch processing aspects of big data. Even if you try to solve real-time processing kind of scenarios, Hadoop would not be the best. There is one component of Hadoop called Hbase. I will cover that I think in the very next slide. That can be used for the real-time kind of scenarios, but again, it has got some, it's a different world. It's not, it is a storage which provides you the random fast access of the data, but again, it's a different world altogether. So it has got some limited capabilities. Okay, Yatish, others, I hope you have just got the answers, right? Again, I have missed quite a lot of questions in between, but again, guys, I was looking at the questions tab and these were like, the common questions. Okay. Now, so when I talk about Hadoop ecosystem here, so this is how typically your Hadoop ecosystem looks like. Okay, so now if you look at the Hadoop ecosystem, right now I would ask you to please forget about yarn, and of course if you're forgetting about yarn, then you should forget about the yarn frameworks. For now, assume that they don't exist. I will immediately explain what exactly are these things. So if you take them away, then you have something called HDFS and MapReduce framework. Okay, So HDFS is the storage component of your Hadoop ecosystem. When I say storage component, as I said, Hadoop HDFS stands for Hadoop Distributed File System, and it provides you the storage capabilities. Whatever data you are going to save, just save it in HDFS. Now, I told you that Hadoop is a distributed system, right? Consisting of multiple machines. So typically what happens? When you are saving a file on your machine, you just know the location. And from which sector of your hard disk did it come? Do you care about it? You never care about it until unless you have to repair it, right? The same is true. But in the case of distributed file system, you will just say, I want to store my data at a particular place. Now, from which machine does this data come from? You don't really care about it, right? So HDFS, right? HDFS is actually a distributed file system, which is kind of an abstract layer on the underlying machines, right? So you just provide a file location, store the data, and whether that data is stored in a single machine, in 10 machines, in 2 machines, none of your worries, right? It automatically brings back the data or stores the data, right? That is one. Then MapReduce framework, okay? MapReduce framework is another core component, okay? So HDFS and MapReduce framework are the core components. If you look at this entire ecosystem, okay, you can take out everything. You can take out Uzi, you can take out Hive, you can take out Pig, you can take out Yarn, Hbase, everything. But you cannot take MapReduce and HDFS out. That's why we call them as the heart or as the core systems, okay? You could not have any Hadoop ecosystem without these two. These are the core components. Everything is built on the top of it. So just like HDFS was your storage component, MapReduce is your processing component of the data. When I say processing, it's about it's a different paradigm of the data. It's a different paradigm of processing the data, the data in a distributed fashion. Okay, so basically it's a different style of coding, and once you follow it, then how exactly your program is going to run in a distributed fashion, that is the headache of framework, not your headache. You just code it in a specific style, and then how exactly it would be executed, that's the headache of the framework. Okay. Now, having said that, it is very easy to say that you can code in a specific style and then you can get the output. That is fine. But there are not many people are very good with the programming, or not many people are very comfortable in programming, let's say in Java and things like that. So there are people who come from the SQL background or from the data flow kind of a background who want to leverage the power of Hadoop without knowing MapReduce. For them, you can actually see that there is something called Hive and Pig latent. So these are the wrappers which are built on the top of Hadoop. So Hive looks like something like a SQL kind of a language, almost SQL kind of a language, wherein you just write your SQL queries and as if you are exploring the tables, and then it gets converted to the MapReduce jobs, and finally it manipulates the data on the underlying HDFS. Okay, that's why you are seeing that these two are sitting right on the top of MapReduce. Pig provides you a data flow language called Pig Latin, almost like Hive, but there are some subtle differences. We will cover them in detail in the course. So that allows you to write the data flows, and then again they get converted into the MapReduce framework, basically MapReduce jobs, and then they manipulate the data. Then you have Hbase. Now Hbase is something which you can see that is directly accessing the data, okay, the HDFS without MapReduce. So this is the one which provides you the real-time access to the data, okay, and this is called the database of Hadoop as well, okay. And basically Hbase is the one which gives you the random and fast access of the data, yes, but it is not an RDBMS. It is the NoSQL database, okay. So it has got some limited capabilities of NoSQL kind of operations only, and or the columnar database sort of capabilities are provided. Hbase is the one. And then Once you have all of these capabilities, in order to schedule or in order to create a workflow out of it, let's say you have a requirement wherein you have to write a MapReduce job, then a Pig script, and then finally you want to do some sort of Hbase query on the top of it. If you just want to do these kind of solutions and you want to automate them, Uzi is the answer, which is sitting right on the top, which basically helps you to create the workflows out of it. Now all of this is very good, but all of this is dependent on data, right? So how do you put the data? The answer is you have got two things called Flume and Sqoop. Okay, so Sqoop is the one which is responsible for, let's say, getting the data from the RDBMS systems, or getting the data or putting the data into RDBMS systems. Similarly, Flume is something which is very interesting, and wherein, let's say, you have to get some sort of unstructured data from the internet, and probably, let's say, some of the tweets from the Twitter API and get into HDFS and do some sort of processing. Flume is the answer for them, right? Now, I didn't tell you about Yarn and the frameworks. Basically, guys, these are the, over the period of time, MapReduce framework is improved, was improved, and then so the MapReduce framework earlier was not only doing the computation, it was even doing the resource management. Okay, resource management also was done by MapReduce framework in the earlier versions of Hadoop. The newer versions of Hadoop are coming up with Yarn, wherein what they have done is they have taken the pure computation into MapReduce framework, and then entire resource management is now done by Yarn. So now, since the resource management layer is separate, so just like MapReduce, if there are other Yarn-based frameworks, like there are something called Giraffe or Spark or Storm, etc., they also can explore the data of HDFS. Okay, so that's the only difference, with Yarn. More on that when we'll be moving to the class, right? So at this point, I would do a quick stock check. Of course, I'll just pick and choose some of the very popular kind of questions. Why is Hadoop called an ecosystem? I think some people have asked this question, so I hope you have already got the answer about it. It's an ecosystem because it has got many components. Framework, it's like framework which has got many components. If I put them together, we are calling that as ecosystem altogether. They are all, put together, they create a system in itself, right? Rajesh and others who have asked this question. Somebody says, Vishal, could you please quote an example for semi-structured data? So XML, JSON data, right? Abhiram, others, right? So XML data and others, you do have some structure, you do have some tags, but what will be the depth of the data? You don't know. That is semi-structured data. Probably unstructured data. If you talk about unstructured data, you have human readable text. Whatever question you have typed, that is unstructured data, right? Whatever I'm talking right now, that is unstructured data, right? Praful says, what are the security promise of, or what are the security promises for Hadoop? So Hadoop is just a framework, okay? Hadoop is just a framework, and it is providing, so there are some of the security tools, something called Sentry, and then there are some of the things which are built on the top of Hadoop, or there are some of the third-party systems like Kerberos, and then there are several others which are ticket-based systems which can be integrated with Hadoop to provide the security systems. There is nothing inbuilt as such. Okay, Praful? So yeah, with this, I'll just be moving to the next part. I would be more than happy to, take more questions from you guys, but I hope you understand that, your time is also limited, right, for this. So with this, I'll just move to the next part, which is about, so guys, what I am trying to do, I'm into the last part, okay? I'm into the last part of the session from the perspective of hands-on, or from the perspective of the technical things of it. So out of various things, we thought, what can we show you? What can we show you by, doing and things like that? And then we found that we can just show you a quick feel about Hadoop. And then we can just show you a small demo about Sqoop. Okay, because many people, most of the people are aware of RDBMS, most of the people know what exactly a database is, how exactly a database looks like, and then what we can easily do is we can just show you how to bring that data, let's say, into HDFS, right? So in between there would be some of the things which you might not even be aware. What is HDFS? How did you install Hadoop? How did you install Sqoop and other stuff? Of course, those are the things which are the matter of, actual classes. But yes, these things may just excite you that yes, there are some of the tools and we are just showing them in action, right? So with this, I'll just move to my machine, wherein I'm just showing, these are just some of the screenshots wherein we say that if you really want to check Hadoop, how do you really check it? How exactly do you do the listing of the directories and other stuff, and then I will quickly talk about the data loading techniques there. Okay, so I'll just move, just a second guys. Okay, so guys, right now I'm going in a full screen mode. And if I just want to know whether Hadoop is installed or not, I just need to type Hadoop. Okay, when I type Hadoop, I will get multiple options, that these are the various things which I can do. Now, most of the people who are aware of Linux and other background, then they know how do you list out the files? How do you list out the files in Linux? You just, what is the command? The command is ls, right? The command is ls, and similarly, if you know this, then very simple thing is, typically you just put Hadoop fs hyphen, and whatever is the Linux command, that becomes equivalent Hadoop command also. So if I just want to know what are the different directories in in my HDFS, I just need to say Hadoop fs hyphen ls and let's say enter. If I'll do this, I will get what are the different directories which are available. Or if I just say this, now, if I say Hadoop fs hyphen ls slash, then the result is separate, something different. Do you understand what is the difference between these two commands? Hadoop fs hyphen ls, simple, and then Hadoop fs hyphen ls slash. What do you understand from them? So basically when you say slash, that means you are going for the root directory, right? I hope those people who might not be from Linux background, you might not understand. Don't worry. For such people, I'll come to that part. For such people, we have created some self-paced Linux as well as Java modules, which will help you to get up to the speed. I'll come to that later. So these are just some of the ways of exploring your HDFS. Now, let's say I'll just show you PWD. Okay, I'll say ls, and then I will go to, or I'll say ls input lab. Let's say guys, I have there is a file called cat inputs lab and states input. If I just do this, then there is some sort of random file which is there, right? Let us move it, let us load it to HDFS. There is one way, wherein what I'm doing is I'm saying Hadoop fs hyphen mkdir. Mkdir is the command to create the directory, and I'm creating a directory called demo. Okay, if I do this, then the directory is created. How do I know whether the directory is created? I just need to say Hadoop fs hyphen ls, enter. You can see that the directory called demo is created. Now, I want to move this data, this states input to demo. So the simple command is Hadoop fs hyphen copy from local. Copy from local is a command, and then I will say inputs lab slash states input. I just want to move it to demo. Press enter. You have now the data available. So how do you know? You just say Hadoop fs hyphen ls demo. Now you can see that the file is available. How do you see the contents of this file? All you just need to say is Hadoop fs -cat. Cat is the command, right? So I just said Hadoop fs -cat and then this, right? So you can clearly see that the content is exactly the same, right? So content here is exactly the same here, right? So this is where it becomes very important. By the way, guys, are you all able to see my screen? Were you all seeing the commands, whatever I was running? The file which you uploaded was a text file. Yes, it could have even be it could have been even an image file also, no problem. So Abhishek, and probably somebody was saying that you are not showing your screen. Just in case if you're wondering, that was my virtual machine, and which I was running on my system itself. Okay, so this is the place. This is the place wherein you loaded the data from, let's say, a Linux path to HDFS, and then you can do whatever processing you want to do. That is something which I'm not covering today. But guys, many times the data might not be present. Okay, many times the data might not be present in the Linux path to you, right? The data might be in the RDBMS, right? So I'm taking another example of, in that case, you will be using something called Sqoop. Okay, Sqoop, I told you, right? Sqoop is the one wherein you can export the data, import the data from RDBMS. So let me just clear it up. Let me just show you. I'll say MySQL. I'm logging in as root user. So MySQL typically, what happened? Minus password. And then if I say show databases, there are various databases. Okay, so I think I will say use Sqoop underscore input, and then I will say show tables. If I say this, then there is a table called employee, and all I'll do is select star from employee, enter. It clearly shows me that there is a table called employee in which I have just created three just dummy records called Vishal, Vijay, Vinay, and some amount of data which I have just inputted here, right? So this is the case wherein I have a table right now. Okay, I have a table right now available in the MySQL. I just want to move this data to the HDFS, right? So now I'll just exit out of it. I just wanted to show you that yes, there is something which is available, right? Now, if you want to use it, then there is a tool called Sqoop. Okay, so if you just say Sqoop help, don't worry, you might not get anything on your machines because you have not got it installed. In the classes, we will be showing you how to install and do the things like that. So right now, I have got the Sqoop installed, and all I have to do is there is a specific command which I kind of kept ready. I don't really want to mess up in the class, so I always keep my commands ready. Okay, so what it does is it basically helps you to so the command is, I'm of course just explaining at a very high level to you. You just have to say Sqoop import. When you say import, it means you are importing the data from RDBMS to the HDFS. There is a separate command for export. I would not be covering that today, but yes, you can easily export the data from HDFS to the RDBMS table as well. So instead of this, I'm just using import, and then I'm going to say connect. You have to specify what is the driver you are using. I'm using JDBC MySQL driver, and then localhost, Sqoop input is the database, username is root, password is password, table is employee, and M1, I'll explain about that sometime later. Basically, it tells you that single mapper thing. And when you do this, then just say enter. In that case, this guy, Sqoop, is actually bringing the data. It will actually fire a MapReduce job to bring the data from your MySQL database to HDFS. Okay, so let it run. It will run very quickly, I think. And that's where I think some of you can easily understand that, so now how do you check whether the data has come? The simple answer is do Hadoop fs-ls and enter. Wow. See this? You want to see whether you got the right data or not? Just say Hadoop fs-char and then employee. Ta-da. Right, guys? You saw just now, did you saw that? Right? So the table is maintained as a file in HDFS. Yes, as a directory in HDFS. Right? Can we import the data with where condition or column wise? Yes, you can. Of course, there are various flavors of it. And then the syntax changes a bit. But yes, for the given time, I just wanted to show you the capability. Of course, there are various variations which are possible and we'll definitely be covering them in the class. Right? So I'm looking everything that you're showing. Okay, that's fine. So with that, I think, yeah, so most of these is something which, the slide tells. Now, you can look at the slide and actually you can clearly see that, yes, it can easily be. This is what I just showed you, that you have the data from various databases you want to load to the HDFS. You can use the copy commands, you can use the Sqoop, you can use Flume, but guys, Flume, it is very, very long. It's like the demo itself takes around 1 hour. So, it needs you to create a Twitter account, create the developer API, get the secret tokens, apply them, and that's why we typically provide that as the manual. So these are step 1, 2, 3, 4, 5, kind of things, and which can easily be followed. So that is something which definitely will be covered in the classes. Some of the things you can use copy from local. In fact, there is a synonymous command called put. So just like I use copy from local, you could have used put, and that's it. The remaining syntax remains as it is, source and destination. Distcp I'm not going to run, but it is, you can easily see that. In fact, I can do right away as well for you. So what I can do is, if I just have to run a distcp is a distributed copy. So distcp will be used if you want to copy the data within HDFS from one location to other. So I just created an employee, right? Employee folder. I will say employee copy. Okay. Oh, sorry. Hadoop dist cp employee and then employee copy. So it basically creates the another copy of the data within HDFS. Okay. So this is another way of manipulating the data. Now somebody says, how about the unstructured data? How will it be stored? For example, video file, etc. All of the data will be stored as if you are just storing that in a specific file system in the binary format. Only thing is, it's not the storage which is your problem, Anshul. The problem is the processing part of it. So when you talk about processing from the MapReduce side, you would like to convert that binary files to the sequence files and then do the processing, right? That's a different part. There is still one example which we have covered about it, right? So this is where the Sqoop demonstration comes into the picture. Now I'm just moving to some of the very interesting interview questions. I'll quickly touch base on those before moving to some of the specific things about Skillspeed. So I'll talk about that very quickly. Somebody says that will you be covering video file processing? Are you talking about the course? See, when it comes to the video file processing and other stuff, it's a completely different ball game altogether, right? Because you have to do about image processing and other stuff. But yes, we definitely cover some of the examples about the image files, right? Because more than that, it's not really just about the MapReduce. It's a different domain. So somebody needs to know what are the fundamentals about image processing, what exactly is digital signal processing and things like that. So, but still we do cover about the image file processing and other stuff. in the classes. Video files and all we don't really cover, because that becomes too much of a domain specific thing. Okay, now I'll quickly come to some of the interview questions. So what is the use of name node in HDFS? So guys, typically this is the example, this is the typical question which you can expect from people. Name node is actually kind of a master in HDFS. If for now you can just understand that if there is no name node, you do not have any uses of HDFS. All of the data, whatever you are storing, name node is the one which is responsible for all of the operations, whatever you can do with HDFS. All operations will happen only and only via name node in HDFS. Okay. What is the data node in HDFS? Data node in HDFS is actually a system which is going to store the data. Okay. So it's like your slave. So if name node is the master, data node is a slave. Any like your machine, it's going to be a data node. My machine, it's going to be a data node, but name node is going to be a bit stronger machine in the this thing cluster. What is a job tracker? So the role of, so just like you had the name node, okay, just like you had the name node in the from the perspective of storage, you have the job tracker from the perspective of processing. So job tracker is the master from the processing side, just like you have the name node. So every MapReduce job, whatsoever runs in your cluster will be tracked by the job tracker. That is very important. What is MapReduce? So guys, I think I quickly touched about it in the class, in this thing, right? That what is MapReduce? MapReduce is a different paradigm. It's a different way of expressing the problem, wherein you express your data in the form of key and value pairs, right? And then the framework takes care of processing it in a distributed fashion, right? So MapReduce is actually a paradigm of distributed processing of the data. Then how does a Hadoop application look like on a basic component? So guys, if I ask you this question, I expect the answer like basic minimum MapReduce application needs at least 3 classes. It definitely needs a mapper class, it definitely needs a reducer class, and then definitely it needs, or at least a mapper class, if not reducer, then a mapper class, a reducer class, and then a driver class. The driver class is the one, it's like public static void main sort of thing, right? So it definitely needs these 3 classes in a Hadoop application altogether. Then if you want to keep on increasing the complexity, you can have a combiner, you can have a partitioner, you can have a custom input format, you can have a record reader and things like that. That goes into a different area. But yes, these are the basic minimum things. This is how a basic minimum Hadoop application looks like. Okay, that's where I think most of my technical coverage ends. But now there are some of the things which is wherein I'll just tell you about the way we plan to cover all of these contents in the course, and how exactly what exactly are the specific USPs about our course. So these are some of the job trends. Again, I don't really need to tell. Of course, you are attending this webinar because you already know that there is this upsurge in the Hadoop jobs in the market, right? So before I proceed, there is a question from Rajan wherein he says, is the Java program knowledge required to work on Hadoop? Yes, if you are working on the MapReduce part, but it is not really must if you're, so it depends upon the job profile. If your job profile is of the analyst and or the data flow kind of a person, then typically you can survive with Hive and Pig only. Okay, but if you want to extend them or you want to do some sort of a Java MapReduce processing, then you have to know Java. But don't worry, for that we understand that there are many people who are coming from those backgrounds which are not really Java driven. We have created some sort of basically 3 different modules of self-paced Java concepts which will enable you for the Java related part. So whatever is required, that Hadoop or Java for Hadoop That's the name of the session, and we have just covered those concepts. So it will enable you in this direction, right? Okay. Now we'll just continue about it. So guys, this is how we just plan to cover. Basically, our entire course is going to be in the 5 modules altogether, or sorry, 10 modules in 5 weeks. Okay. The first week we are basically into the introduction of big data and Hadoop, a bit of whatever you have heard right now in much more elaborated fashion, and then we typically get into the internals of SDFS and data loading, other techniques also. And then the second week is where the most of the action begins in the terms of MapReduce and the advanced MapReduce concepts. Third week we typically talk about Pig and the advanced operations in Pig, and it's going to be very exciting for the people who are not really from the Java background. And week 4 is actually for the people from the SQL background, advanced Hive concepts, Hive, introduction to Hive, Hive concepts and extension of Hive, and then the introduction of Hbase. The 5th week we typically go ahead and talk about the advanced operations in Hbase and a bit about Uzi, and then last but not the least, it's about the project setup discussion. So that is going to be very interesting kind of a class wherein we just throw upon a scenario and then we discuss as if we are actually a project team, and we are deciding what will be the implementation strategy up to the production. Okay, up to the production part of it. So those are some of the things which we cover. For those people who would definitely like to evaluate before they want to make some decision about whether you want to go ahead or not, there is a free trial of the class which is available, and wherein more than 3+ hours of training material is available. Access to assignment and quizzes also is available there, and it's like your real classroom experience. Of course, you will get all of that. And then there are some sort of personal counseling sessions where we typically hold one-on-one sort of sessions just in case somebody requires an extra clarity at the end of the session. So those are some of the things which are available in the free trial as well. You can, how exactly you can just do that, just visit the Skillspeed website and then click on Big Data and Hadoop courses. It will just take you to that page, and then there you'll see a button called free trial. Just click on it and you'll just get started. So it's a free trial of the course. Definitely you can just try before making up your mind. Please don't treat this last slide also as a marketing kind of a thing. It's all about just, these are some of the things which I and some of my colleagues have prepared, and what really sets it different. It's about the course curriculum is not from the concept perspective. I'm not here to teach you MapReduce. I'm here to teach you how to apply MapReduce in the industry. So in the job. So that is something. There is a critical difference between them. Knowing something theoretically and knowing how to apply it. That our focus is on the latter part. The sessions are going to be virtual sessions just like you are seeing right now. Only thing is people will be much lesser in a batch, and then there will be much more interaction. There might be a lot of people who are just starting their career in Hadoop. So for them, they might need some sort of placement assessment. Yes, it is provided. Also, the content is not going to be just limited to the duration of the course. It will be lifetime. So whatever you have paid for, it will be accessible all the time for you, even after the completion of course. And then of course, if you are learning, then questions, doubts, problems are necessary. And for that, support is also available 24/7. So there will be an email, there will be a contact number also which will be provided, and we highly encourage you, to send your queries or just pick up the phone and call back the support team to get the help. Right? If you need more information, if that excites you, if you need more information, lines are open for. And this is the typical, this is the phone number on which you can contact. This number is available on the website as well, skillspeed.com. Okay, so that's pretty much of it from my side, guys. I hope I have not overrun the time by too much. Yeah, I'm over by 10 more minutes, but I just hope that it was useful from the value perspective to you. And with that, if that excites you guys, then definitely we'll definitely meet in the batch, in the class. Okay guys, see you there, and logging off now. Thank you guys. Thanks for appreciating and giving your time.